So part 2, we're going to talk about the initial planning of a WLAN or Wi-Fi system. So if this is a new construction, say a brand new building going up, then in a lot of cases you're the IT contractor, but there's a general contractor who's responsible for a building, the entire building, and the client hires you separately from the contractor, and your job is to just do the IT, or even possibly your job is just to install or design the Wi-Fi. And so you have to coordinate with the GC and with other subcontractors on site. And part of that means figuring out a schedule to install your wiring, install your equipment. You can't just walk in there and do whatever you want, because there are guys doing framing, there are guys doing electrical, there are guys doing plumbing. You can't all be in each other's way. So the other thing that you have to think about is on a construction site with a larger construction company, there are all kinds of policies. You have to wear a hard hat, you have to wear steel-toe boots, you might have to do a safety orientation, which could take you an hour or it could take 2 hours. You have to figure out like what your work hours are going to be. The general contractor may, let's say, you can only work from 9 to 5, so you know if you've only got 3 days and you got to work 9 to 5, you can't work late. Do you have enough time to complete the project? And all these constraints can cause delays or increase your costs, and you have to factor that in when you price this job out. So in many cases, not all, but it depends on the project and the drawings and the architect and the client. The GC may be responsible for installing wiring, conduit, raceways, network cabinets, that sort of thing, and he might subcontract it to his electricians or laborers. So you need to figure out who is responsible for that part of the project and work with them. And of course, some of them cut corners. It's a fact. Things that they've done, besides like horrible delays and damaging equipment. I've had GCs not install wide enough conduit, or use a like flexible conduit that you can pull a cable through, not bolting things down, using a really cheap Chinese cable, not terminating the cables correctly. For the most part, electricians don't know how to run data cable, and so if you can't run your cable, or if somebody ran the cable for you and it doesn't work, that's going to make your job difficult. So how do you prevent that? Well, you need to be on site, and you need to be inspecting things during the construction phase and communicating with the contractors and with the GC and with the client. So, if something isn't being done right, you need to explain to people. It has to be redone properly. Otherwise, it's not going to work. Put everything in writing. That helps with your warranty in case there's a dispute later. So, you need to look at the blueprints, because in some cases, in many cases, the architect drew a building and he decided where every AP should go, where every network cabinet should go, where the IDFs are, where the MDF is. And they are not experts in designing a Wi-Fi system. Neither are electricians, neither is the client. So their locations might be just a bit of a guess, and you need to go over that and see if it's gonna actually work based on what the client needs. So ideally, you'll be involved in the project before construction even starts. maybe not. Otherwise, you're going to have to make some changes, and making changes is not always easy, because if you're not pulling the wires, or you're not installing the conduit, then the GC has to get his electrician and do that for you, and if it's too late and they already ran drywall and whatever, so that's going to cost more money, and the GC is not going to do something that costs him money unless the client is going to pay him the money. So you need now to look at, say it's not a new building, it's an existing building that needs Wi-Fi. You need to go over there and you need to get floor plans. You need to get an idea of which areas need Wi-Fi coverage. Are these areas indoors or outdoors or both? What kind of rooms you have? Are they warehouses, offices, cubicles, and what the walls are made of? Is it drywall, brick, concrete, lead? This is very important in terms of successfully designing the Wi-Fi system, and we're going to see why later. And so you need to also know where each MDF and IDF is, and they could be anywhere. Don't think of a MDF like a Google data center. It could be under somebody's desk. Just a small building. It might just be a switch and a router in the corner. It might be on top of the fridge in the lunchroom. You never know. And you also need to know where you can install APs and where you can't install APs and IDFs. They may say, hey, this closet is for our janitorial supplies, or you can't install an AP here on this custom mahogany wall or whatever. And they might have certain aesthetics. They don't want to see the APs or whatever. You also want to see if there's existing wiring that's actually working, and I have to emphasize that the wiring is actually working. Wiring that already exists, it could save you a lot of money. It could save your client a lot of money, so that you don't have to run new wire. Same with conduit or raceways or J-hooks, especially in situations where it's impossible to run new wire without getting a sawzall and cutting through the roof. And you want to figure out where you have ceilings and what kind of ceilings you have. So are they open air, dropped ceilings, ceiling tiles, is it drywall? Are there access panels in this drywall ceiling so you can get upstairs in the attic or whatever? And you want to see if there are working power outlets anywhere, especially where you're going to install network equipment or even access points or antennas or repeaters, which we'll talk about later. And again, I emphasize they need to be working. There are always power outlets that aren't working. They'll be totally useless to you. And you need to look at the hazards. Is there asbestos, confined spaces? Are there rats and mice and things? That's going to complicate the project, complying with the safety, occupational health, everything like that. Well, messed up projects, not messed up in terms of the way it was done, but in Red Deer, for example, they had a hospital that had a Wi-Fi upgrade, and they had a decontamination procedure, and could only take one ceiling tile out at a time to go look in the ceiling, and you had to vacuum that ceiling tile before you took it out, and then you had to take it out and keep vacuuming. They didn't want the dust to contaminate the air in the hospital for health reasons for their patients. So you need to think about also if the client wants to have Wi-Fi in a stairwell and an elevator, in a parking garage. These things are built out of solid concrete, and your Wi-Fi doesn't really get into those areas, so you have to put additional APs, which means additional wiring. Typically, you would put APs at each elevator door or each stairwell door or inside the elevator shaft. And it's very expensive, and you need to think about if the client really needs that and if they want to spend the money. And then you need to talk to people. So you need to look at each room in the building and figure out how many people or how many devices are in each room, that are going to be on the Wi-Fi, because that affects the number of access points that you're going to install more than the size of the room. And you need to ask yourself if those people move around with their devices. Is this guy on his phone or laptop and he's going from office to conference room and he needs to move around and stay connected to the internet? And also how much data each device uses, because you could be on your phone or you could be on your computer and not doing anything, just connected, or you could be video conferencing or streaming videos or whatever you're doing and using a lot of data, and that also affects the technology that we need to install. And if there's existing Wi-Fi, we need to figure out why it sucks, basically. Maybe it's a good network, but it doesn't cover the whole building. There are areas they renovated or whatever, and they need more coverage. For example, we have a client that has an office space and a warehouse, and they now decided that the warehouse needs Wi-Fi 2, or maybe their Wi-Fi is only 2.4 gigahertz and they've got a lot of 5 gigahertz devices, and they want to take advantage of being able to use them to their full capacity. Or their Wi-Fi is not secure, or they have good coverage, but now they added smartphones and tablets, and now there are too many devices, they're too dense, and then they're all competing to get a signal with the same access point, and now it's overloaded. Or even the structure underneath, now you've got cheap switches that don't have a capacity to handle all the traffic. And you need to ask yourself what I said earlier. Are you replacing the Wi-Fi, or are you just adding to it, and maybe it's not dense enough? So with the passive survey, which we're going to talk about now, what you need to do is figure out where we have Wi-Fi interference in our building. So it doesn't matter if it's new or old. There's nearby buildings and nearby offices, and they have Wi-Fi, got Wi-Fi before you. So if your store in a shopping mall, and there's other stores in the mall, or the mall itself that has Wi-Fi, and the signals from the other access points are going to interfere with yours. Or if you're in an office building, the tenant above you or the tenant below you has Wi-Fi, and you're going to have Wi-Fi, and their Wi-Fi is going to interfere with yours. So we need to figure out where the sources of interference are. Other things cause interference, even like microwaves. And you need to be careful here, because the sources of interference may not always be running. Somebody may be on their phone only a couple hours a day, but that a couple hours will disrupt you. So if they're on their phone at noon and you show up at 2 o'clock to do your survey, you may not pick up the interference. So we use AirMagnet or ehZee or whatever it's called, and we can take measurements. So check out a video on AirMagnet where we go over performing wireless active and passive surveys and designing networks with AirMagnet. I won't go to details here because it's in the other video. But basically, you get a heat map. And the heat map, red shows us, in this case, the areas with the largest coverage, and blue shows us areas with very little coverage. an AirMagnet, it's yeah, it's pretty much the same. So one thing we need to know that's very important based on what we talked about is SNR, also known as the signal to noise ratio. And so we're not gonna again get into the mathematical equations, but basically if you take signal or strength and subtract it from the strength of the noise, you get the ratio. You don't get the difference, you get the ratio because of the math. And again, I'm not going to go back to grade 11 or whatever it was where they taught you logarithmic scales, but just know that the signal to noise ratio is signal minus noise. And the signal is going to come from the APs that you're going to install, and the noise comes from other devices. So you need an SNR that's over 20. And basically what we're saying is that the signal is 20 times the noise at any point in your building based on a design that you're going to make. If the signal is too weak or the noise is too high and the SNR is less than 20, then you have too much interference, and that's not good.